Volkov. I will take the SMTP server for Asyncio, and I will tell you what we needed it for and what were the challenges. So, what is the reason why? We had a necessity to write email security service, and it is for filtration. We had to manipulate the mails and all the other things that we face every day, like phishing, spam, viruses, etc. And it is the corporate cloud service that is supposed to be reliable, failure-free, and stable under load. And we had more than 1 million users that used our services, and of course the project should meet all the corporate practices, instructions, procedures. It should be also agile, it should have an agile configuration, and of course it should be integrated with all the other internal services, and it should have a guaranteed quality. And of course there are no ready-to-use solutions. It was a new project, which is a start of every story. And what was the beginning? Sorry, it's... okay, a few background. Some background. So when did the SMTP protocol came into being? Quite long ago. The first email emerged in 1965, and the SMTP protocol emerged in 1982, and it exists unchanged until now. And the Python one is in 1994, so 13 years have passed. Then we have SMTP Lib Library as a part of Python, not in the version 1, and then Python 2, and I think the developers have an experience of working. So it appeared 18 years after SMTP, and then in 2001 we have SMTPD Python with the support, and it appeared in Python 2 only. And we have extended CMTPA, which supports the extensions, plug-ins, and the other useful things. And in 2014 we have IOSMTPD and IOSMPTB Lib, which are the similar to the libraries, but it has got a new features. And where we are now in 2017, we can see that these are not a fresh technology with a difficult history, and that there were new implementations which were interpreted in the protocol accordingly. What is SMTP? It is a simple protocol. It starts with the greeting header. Then the client, the server says OK, and you can see that there are text commands, and the exchange of the messages is pretty straightforward, and it is very comfortable. The server might reject it or say OK, and we have the sender and then the recipient, and the server is saying yeah, OK or not. And if there are a few, then we execute a command from very start. This makes it possible to send letters to the receivers at one go, and if it's not possible to send it to somebody, we will learn about it right away. Then the sending letter, and the server says, OK, ready to send it, and then we send, and then we have R and N. That's the exchange of messages. What's so different about ESMTP? Instead of hello, it is E age low, and it means that the new version of the SMTP is supported. It is the client that governs or rules which protocol to use, either the old version or not. The whole range of the extensions could be sent, and based on what extensions are supported, the procedures are applied. It is quite a tricky coding in the SMTP. So that's how the protocol is built. Different versions of protocols could be supported, and there are a lot through the 30 years of the existence of the technology. Quite an interesting command is start TLS, and this server is ready to receive it. And then we have the handshake coding. Quite interesting things that implemented, not that trivially. And before the new implementation, we analyzed what is available. We checked the SMTP Lib Library. It is more than 20 years old, and it supports the SMTP protocol and the SSL and Start TLS. All the features that the programmer might need are available, and it is actually a shell for the work with the socket. That's a small listing. Everything is straightforward. It is building Mac file around the socket and then read line. Since the library is that of the client and send no complications. One command, another one, read line, push, and everything goes. Much more complicated when we make a service. It is younger a bit. It is 17. It is based on framework AsyncChat Async Core, and the AsyncChat and Async Core is a prototype of the future Async Kio. The library itself does not support either the Async or the coding. I will explain you why. First, what is the structure of the library? Like in the Asyncio, we have a selector. It is the prototype of the loop, and there is an SMTP server that could be registered in loop and open the port and listen for it. And STP channel will be set up. And the object will be created, and the SMTP channel makes magic related to implementation of the protocol. And if we want to develop the respective properties, and we receive the letter when it is applied. It's not possible to manipulate the process, and not possible to do encoding. And it is related to how the work is done in the core itself. The difficulty of implementation is as follows. When the data are received, the Asyncio informs the file terminator call, and then we should respond to the data that is received. And we should implement the command either and the command might have many lines or one line to make the code very complicated, and it's not understand how to do magic of the encoding, which we will have to wrap the existing session into SMTPL. So after I analyzed it, and not all the things suit us for a new project, and we analyzed AOSMTPD of the same author, and it was transferred into the new realization of Asyncio, and it has got the new things. However, the Asyncio exists in the box, and we were not satisfied with the those two things because the SMTO has got the basic implementation, and it's no good for a large company, and SSL encoding was any good. However, it was the best solution. We took it as the foundation for our work, and we started to deal with it, and we got the full SMTP support, and thanks to Python we can disassemble any library, and the most interesting things are related to encoding. No trivial solutions did exist, but a few words on how are the things. The SMPTD is a much more fresh technology. Here is the loop. It's the factory of our protocols, and we have transport level, and separately we have the protocol level and the handler, which will be handling things at the client side. We don't need to get into the protocol, and the handler will be dealing with it, and the protocol will get the required methods. Asyncio has got such a thing that the protocol and transport are at different level, and then we have stream writer and stream reader, which are accumulators of sending and receiving, and you can just draw the required data. We say read line, await, and that's it. It is much more convenient because the code is native, it looks like a protocol, and there are no difficult fancy things like at the time when we were dealing with the library. So what did we need? We need to have more control over the SMTPT section. We got into the preset, and we should take decisions, and it was not possible to do that, and it is important for us. So why should we receive the letter or keep the session on reception? We should have context between different canal, and so we had, if we make receipt, we should understand for which user, and in terms from the sender, and we should have a context between the nets. We need encryption, and we cannot do without encryption, and of course we wish it to be stable, because after we started production we uncovered some unpleasant things in the library. There were some surprises, and it was necessary to clean up the code, because the original library was just similar to the SMPD, and there were fragments of the solutions that we did not plan to use. So before encryption, yes, by the way, first we broken down into these pieces to develop the context between sessions. We have set up objects in the library, and then we started encryption. And encryption was did not materialize, and I looked into it, and I found the module with the header. It is the reference to Yuri Selivanov, who is the developer of the SMPCO, and it is a lot of magic, and then the expectation that we would choose something. So the question mark is whether we could start production. We'll look into the code further on, and a lot of magic, like legacy of protocols and transport. We moved in some transport. We introduced links and we disassemble stream leader, stream writer, and after that we inherited selector loop, and the bottom line is that's how we put it all into it. So it was quite a heavy patching of async lib, and we didn't feel like starting production with it. And why so complicated? Because there is a cell in Asyncio and it works, doesn't require any patching. It just said open service, and the service is open and everything works. But why? Because the transport level and the protocol are isolated well, and there is SSL protocol that is between transport and the stream reader. It is indeed between, and it does encryption and disencryption, and the protocol might not even know that there is any encryption involved if it is not told. And so why not realize it like that? And we got into the code, we fixed it, we have added we have written a function, and actually we have pasted the sync code from the original library, and I have substituted transport, and I linked those instances between themselves, and I started it. The only thing is that the connection might, and the link over here, it does happen, but at different phases. Sometimes at making, and at some and in some cases at connection made, and it should be taken into account that the connection made will be called twice, and there will be an initialization of the connection. It will be necessary to repeat some of the manipulation. So it is a magic, but in this case as well, but without any major hiccup. Everything was fine and started working just all right. And by that time we would just shoot into our own legs, and we faced that kind of situation at the production level. The first thing is the Asyncio is quite an important thing and can do whatever is necessary, but at the same time, with the huge responsibility, there's great responsibility. With great power comes great responsibility. And the simple example, protocol ping pong, and it's an illustration how to implement the protocol at Asyncio. And we have a handler that reads the line and writes it standing by, and there's a launcher server, and we launch a client and launch it in the loop, and together with the client server, the client in write ping has the ping launched and the ping coming. The obvious thing that you might focus in is the follows. Many, though, do not observe it. I don't know. Any problem? Do you see any bugs from the audience? You should close the connection. The trivial thing. The line is closed, and as soon as coroutines finish, the connection should be closed as well. But the Asyncio does not do it yourself. If you not close it, it will be in the cache memory, and we shoot our legs, because after load it would collapse after a certain period of time. Benefits, there are some nuances with the magic obvious, and of course there's some documentation. If we have that right end of a file, and visually, if it works, if it's run, works in the same manner. But over here, it's not the closure of the connection. Asyncio supports running with semi-closed applications. The writing is closed, but and the server can work right or not, and it could result in unexpected side effects, and if the client does not implement it like that, but does it like that, and if it is a right ping and closed. So what should happen? And of course the deadline will be missed. I will not have the line, the connection is broken, but the line is not read. But if we started, everything works just fine, just as before. And the reason is that the read line has got an exclusion, and if the connection is broken, it will return to us what will come. In this case, it is ping, and the new line will just be there. But if we replace read line with a read until, read until, it is the line, new line, and with the if the syntax is different, and the connection will be closed and the situation will be working in a different manner. However, the data that has not been read is there. In principle, everything looked quite simple on the face of it, but there are obvious things that are not uncovered in tests. You have not thought about it, and then testing, you might fail to notice that certain things are closed or not closed. And we had some clients who would open the connection, and they would either semi-close it or forget to close it at all, and it would result in some funny effects. Another obvious thing, and it cost us some time and nerves, it is patching Asyncio. We wanted to correct what's going inside, and it is the task that is rolling in a loop, and we did some logging that would enable us to do the tracking. Then we had the monitoring, but the point is that at the 3.5 Python that we used, here is by the way loop and the function and the exception, and it reads I am here.
When we decided to update Python 3.6, all of a sudden we had a problem, so we got into the code, and the logic had not changed. Everything seemed to be okay. However, it would not work, so the explanation was quite unexpected, and it was related to the implementation of 3.6. We found this interesting thing, which was hidden by it. So accordingly, what we had there did not have any effect and was ignored. So it was in fact a kind of a surprise to us. And possibly the most interesting part of it. This is the right example. This is what deals with patching Asyncio. Well, these unexpected results really made us quite nervous, and possibly the gravest problem we had dealt with production. After possibly 1 or 2 months of operation, when everything had been okay, suddenly some strange things started occurring. First of all, request timeouts for external service. Some strange messages started coming, but basically everything seemed to be okay. Then, with time, the number of such events went increasing, and they started occurring at the same time of the day. And the worst part of it is that it was always happening on Friday night. Everything started just breaking off, and we were receiving lots of letters from our clients. We had complaints from our customers in the USA and all the other problems. Besides that, we had plenty of problems because working for a big company involves dealing with a lot of departments. In our case, the key customer was based in France and we were in Russia, and we had the people responsible for exchanges working somewhere else, and so on and so forth, each one of us living in a small world of ours. And this is what was happening. We kept saying we have a disconnection with the external server, and they said it is through your fault, and we kept blaming each other. It's not that we were blaming each other, because all of us were quite competent people, but from each side thought that the problem lay with the other side, and we possibly spent a week trying to resolve it while all things were happening. And then we found out that we had task 1, which was dealing with the network. So that DB was awaiting a response, and then it started understanding that it was disabled. Then task 2BD started working, and naturally something was wrong within, and the task only worked for 5 minutes without a single await. Sys loop was blocked without anything happening there. 5 minutes later, task 1 returned the control loop, gave it back to task 1, and it discovered that 5 minutes had passed since the loss of control. And then it said, task 1 said, okay, I'm having a timeout, even though the data were there in the buffer. But task 1 saw a timeout, and everything was gone. It was quite difficult to catch red-handed during production, even though we had 2 different monitoring loops. Everything was recorded, and we had analytical tools to use with lots of timing and event descriptions and so on. However, it didn't help us, because all those metrics couldn't see what was going on outside of our server, and we couldn't monitor the environment around the loop. We could have never expected it, and it took us a lot of time. And even at the end, we couldn't exactly understand why it should have happened at all, of all things. So it was just some kind of unresolved problems as far as we were concerned. And as a matter of fact, after that, the most interesting part of it, when we started just looking for the root causes and discovered that heaps of codes we used and using our own methods and handlers. So we really dealt with the library in a very special way. And the higher the number of codes, the more sophisticated it is. And we understand that it threatens with a protocol error, and that's why it might have turned into a very grave problem, and we didn't want to merge anything. That's why our natural decision was to speak to the author So we got in touch with our bosses, we got their permission. We know that there is a problem with copyright. As a result, the process lasted for too long, around 6 or possibly 8 months or so. So we had done 21 requests during the time and more than 180 comments, and it lasted for months sometimes. It was quite a time-consuming and difficult process with lots of funny things happening over that, and only 10 of our requests were received a reply. 5 of them were fully redone. The original idea was absolutely revised. That is to say, the final request was there, but unfortunately not in the shape that we had anticipated, and 7 requests were just declined. That was quite a funny experience, because the author of the library is Pararashov, one of the creators of Python's library, who has more than 20 years of experience in development. So dealing with this kind of problems always brings about a lot of experience. And it was important for us to consider the declined or change the requests, which means that our solution had been wrong, and that it was important for us to be able to bring in the expertise of more experienced developers. The requests that had been fully changed were based on different visions and approaches with more correct solutions used, while we, from our end, were only using some kind of props. And this kind of collaboration helped us, instead of inventing a bicycle, come up with a commercial solution. So we improved the process, and now it's going to be a very good process, even though it was hard on us. Correspondence took months at a time, and some of the things had to be revised 5 times or so. Nevertheless, it was really quite good experience for us. Your questions, please. My question is as follows. Number 1. You told us about a large number of problems with Asyncio. But what was the advantage of using it then? And my second question is as follows. You said, as I understood, that you have very big loads. What about the performance of Python itself? Speaking about the advantages of Asyncio, quite often we are asked about it. Possibly the technologies on which it is based are not quite elaborated yet. On the other hand, since we had a very difficult service to take care of, it would not be well compatible with other servers. So we had to run a number of things concurrently. That's why we had to wait for all of them to send their replies to us. And if we were to use threads, then it did work quite well. On the other hand, our project showed that Asyncio was not so advantageous to use as we had thought at the very beginning. And besides, we discovered that dealing with letters was quite a time-consuming process. Sometimes it would take us several seconds, which is rather bad for Asyncio. And sometimes certain problems would emerge quite unexpectedly. There was really a cool case when our server sent us and the author is sitting here of the protocol that was used. So they sent us a JSON with a wrong symbol, which was due to the fact that the server that we sent our request to was in touch with another server. And so the wrong answer was discovered when we tried to decode it. So decoding was switched on and tried to guess what was inside, but the size was 35 megabytes, while there were 35 million symbols. And so there was a special symbol for each code. So that was just the case when we actually hit our leg, so to say. So I believe that this kind of quiz took us some 7 minutes to deal with, but then we forgot about that nightmare. And we discovered that our project could provide quite convenient details, because the awaits and the things, and knowing that our code will not be implemented by any other party, it was possible then to synchronize it. But on the other hand, we were limited by one process only, which wasn't that convenient. And specifically in our project, it wasn't so big. As a matter of fact, bordering on the limit which we shouldn't have tried to achieve. So I don't know what we could have done with SyncChat or with trades. Then possibly we would have had to suffer a lot from it. And as I say, with PinCode, everything worked without any special trouble. Then with PinCode, there were not so many problems as far as horizontal scaling was concerned. When I was involved, there were just 3 servers there. I had just met some guys in the lobby. They said there are several hundreds of them operating now. On the one hand, Python is not the most high-performing system. On the other hand, its performance was good enough. And besides that, we have a lot of reserved capacity. So if our one data center breaks down, another one will be able to swap in. And Americans get up at a certain time, then they start writing letters. There are very few peaks of load at night time. That's why we always had to maintain a reserve capacity for daytime here. And on the other hand, there were periods of time during the day when there was no load at all. So we couldn't have any fewer servers. Well, thank you for your presentation. I have a question. You said that you didn't like the patch used for TLS. As a result, you made a patch yourself for transport. No, it wasn't for transport. We patched the protocol that we implemented, by actual SSL has a function dealing with SSL context liberalization. But as I understand, it is linked to the socket. Well, here's the author who could answer your question. The situation is as follows. The author is not using a microphone, so it's impossible to follow or to hear his explanation. In a nutshell, we need to bring it to a certain internal condition as far as the data are concerned. So it's not that hard. However, each one of us has his or her own specialization. I just thought that you were using SSL modules, and then you could request for blocking things. But then we would have to come up with SSL object, and only after that we could switch over to transport, etc. So it wasn't that easy. But why so, if Asyncio is already implemented and doesn't need any props? That is to say, I use the same implementation, but based on my code. So I used the Asyncio paradigm, and everything started working the way it should. As you said, you had 21 requests and 10 of them were accepted. So as a result, what was implemented in the library and what were the things that failed? I had already enumerated them. We added a couple of context entities and envelope which make it possible to use context. We also added some handlers. So what we have now in the library is entirely a project of our own, which moved there. That is to say, all of the changes that we introduced were merged with it. There are possibly a couple of rather contradictory solutions that were retained there. Is that it? Then, thanks a lot to everybody.